Hey, this is chapter 15, and this is about material extrusion and drawing processes. We'll be also talking about some related equipment about these processes. And basically, these processes are about pushing or pulling materials from die. We will discuss the details, but they are highly similar. The main difference between extrusion and drawing is that in extrusion, we are pushing, but in the drawing case, we are pulling the material simply through a die. And we can produce mostly some round shapes or different cross sections, but they are usually longer, and we can easily produce rods, shafts, wires, bars with these processes. And as I said, in extrusion, what we are doing, we are applying force, and with the help of this force, this material, this blue material is actually pushed through a die. This is our die, as you see. We have die backer. We put our billets. This is our original material, round in shape. And then once we apply force at the backside, then the material flows simply through this opening, through this die, and as you see, its cross section is modified. It's a simpler extrusion process. In the initial case, it was cylindrical, and right now still cylindrical, just the diameter is reduced. But we don't need to have such simpler shapes. We can have complicated shapes. You need to spend some time on the die design and have much complicated designs, but this is a simple extrusion process. And with the help of this, actually, we mostly obtain semi-finished products. What are these? For instance, you can see such cases. These are extruded parts. As you see, they're not finished completely. Once you do some cutting, then you'll obtain finished products. So that's why it's called that. It's stated that after the extrusion process, we have semi-finished products. And in this extrusion process, since you're applying too much force, we need to have, we don't want to have any fractures and cracks on the workpiece, but it should be changing its shape. And that's why actually the name comes from Latin words, extrudere. It's about the force out. And we have large deformations on the workpiece, and we have no cracks, no fractures on the material. And as you have seen in the example products, always the cross section is constant. So we can say that with extrusion, we produce 2.5D shapes. You see, we have a kind of a 2D drawing, and it's extruded in this direction. And we may have gears or more complicated profiles. It depends only on the type of die you are using in this process. And another thing is about continuity. And we can say that this is a semi-continuous process, since what we do, we have a kind of a billet, we put it into this chamber, and then apply force and do the extrusion. Once this billet is over, since once you move this stem or ram to this end, we cannot continue extrusion process since there is no material remaining in the chamber. So that's why we need to remove the ram out and then put another new billet and continue with the new extrusion process. And that's why it's called as semi-continuous or batch operation. And the tools are not complicated, you see, and their costs are kind of moderate. You cannot say too low or too high, but it's moderate, in between moderate and low, I can say. And with the help of this process, as you see, we mostly produce simple solid cross sections. And depending on the type of material you are working with, you may increase the temperature and perform a hot extrusion, or if the material is not a difficult material, you can do cold extrusion. And this cold extrusion is mostly combined with forging operations, which means that we have impact forces, and we name these processes as cold extrusion. And in the drawing case, the things are highly similar. The only difference is that instead of the pushing actually this billet from the back side, what we are doing in drawing, we grab this tip of the material and pull it through the die. And so the resulting workpiece has the same shapes with the cases in extrusion processes. The only difference is that we are pulling instead of pushing the material. Now let me briefly talk about the extrusion process. We have seen actually the direct extrusion. This is the basic direct extrusion. And now I will talk about 3 more extrusion processes. The last one is not that important, but we have 2 other important extrusion processes. This first one is called as indirect extrusion, and the second one is called as hydrostatic extrusion. The last one, the least important one, is the lateral extrusion. Now let's have a look at the indirect one. So I think it's better I first discuss the friction issue in this direct extrusion. Now you can see that. Let me annotate this part. And while we are pushing this material, this workpiece here, we always have friction on these walls. See? And we have a die, let's say die surfaces. We always have friction on these walls since we have a relative motion between these chambers, walls of the chamber, and the material. So that's why, since you have a relative motion, then we'll have friction, and this friction may result in higher forces and less surface quality. So you need to find some ways to decrease the amount of friction, and with the help of that, you will be increasing the overall quality of resulting shapes. Another thing I should mention in direct extrusion is the dummy block here. You'll see in between the workpiece and the ram, we have an extra material here. Why we are using this one? Since this process most performed at high temperatures, and if you don't use such a block, then the bottom face of your ram will be actually worn, and you cannot maintain the quality of the ram, and you need to replace it frequently. So that's why instead of replacing the whole ram, what we do, we use a dummy block, and once this dummy block is actually broken or worn, what we do is simply change this little part instead of changing the huge ram. So this is an important issue, and in some cases we need to use such dummy blocks. Now let's talk about indirect extrusion. As the name implies, this time we have an actually difference in terms of directions. In the previous one, it was a direct extrusion, and the material was flowing in the same direction we are applying the force. But this time, this is direction we are applying the force, but material is extruded in the opposite direction. That's actually why we call this process indirect extrusion. Another thing about indirect extrusion is that what we do, we put our material into this chamber once again. We don't have a ram at the backside, but instead we have an actually backing plate. This is keeping the workpiece at the same position. And again, due to the same reasons, we make use of a dummy block, but this time this dummy block is not moving in the direction of extrusion or other direction. It's always stationary. Most of our billets, most of our workpieces stationary. So that's why we have less relative motion between the workpiece and the walls of our container or chamber. And if you look at here, what we are doing this time, our ram or tool is on the other side, and we are pushing our tool into this chamber. Since this region is the volume is decreased, our material will be moving, will be flowing into this opening and go out from this inside of this tool. And that's why we have less friction. The friction is only on this conical, let's say, surfaces, while we have less friction on these walls, which is actually in between the container and the workpiece. So that's why for a bit difficult materials, for brittle materials, indirect extrusion is used. We make use of less force to do the extrusion process. Now let me have a look at the hydrostatic extrusion. The main difference is that, as the name implies, actually, we make use of an extra fluid. In the previous ones, we don't have any fluids. The motion is transferred directly with the help of mechanical means, components, tools. But this time, we are applying this force from the backside with the help of a fluid. So what we do, we apply this pressure and it's transmitted through fluids to the material, and we have triaxial compressive stresses on this material. This is our workpiece, as you see, and we have stresses from all the surfaces, compressive stresses, and with the help of them, extrusion actually takes place. And another thing is that this time we have much less friction actually on the workpiece, since there is no direct contact with the walls of the container. We only have little contact here on the conical surface of the die, but the rest of the surface of the workpiece has no contact with the container walls, and this is highly suitable for brittle materials. But the thing is that it's quite difficult to apply, since you need to maintain a kind of a high pressure inside this chamber, and once you increase the pressure, probably our fluid will be leaking from these sides, and you need to be making use of proper seals, and this is a complicated process. That's why we don't have much examples, much applications in the industry. And we have another one, the lateral one here. As the name implies, this time the direction of motion of your force, the direction of the force and the direction of the material flow is a bit different. We have a right angle in between. You'll see we simply put our material in between here and then apply our force, and we have a die opening at the side surface, and through that we get our actually extruded material. And in all these, the die design is highly important. We have a die angle here, as you see, it's alpha, the angle between the horizontal surface and the conical surface of the die. And as in the case of machining tools, we have a relief angle so that we don't have much friction between the extruded material and the die. And we have another term, it's called as extrusion ratio. It's actually the ratio of A0 and AF, which is the final cross section, and this is the initial cross section. So if you want to apply less force, if you want to do the process with less forces, then you should keep this extrusion ratio a bit at lower levels. And we are not going to discuss the math behind extrusion. This is the topic of actually the next manufacturing course. And we can briefly talk about some issues like if you do the extrusion by using such an, let's say, rectangular die, then what will happen? We'll have some material accumulated around here. Okay, you cannot extrude these materials. They will not be going into the die opening, and these are called as scrap or butt end, and you need to remove them once the process is over, or you may prepare the new design such that you have such angles, and I'm sorry, you will not have excessive material at these corners. And further, we have another issue about extrusion. We can extrude two materials, even three materials at the same time, and it's called as coaxial extrusion. So what we do, we put actually two materials on top of each other here. For instance, this might be one material. Let me draw it once again. That's fine. This might be the internal material. Let me use another color here. And that might be the second material you are using in this extrusion process. And once you complete it, then it's called as coaxial extrusion. And the thing is that the materials you are using in this process should have similar mechanical properties. Otherwise, the same extrusion force cannot be able to extrude one of the materials. This is an important issue. and we can, especially this is useful for coating some, let's say, materials with different uh, materials. For instance, this might be copper, and you may be using another material over it, some maybe hard plastics. With a single extrusion process, you can cover the outer surface of the copper wire with this coaxial extrusion process.